dear students, welcome back to my class. In the series of learning programming in C, in the previous video, we have discussed about how the user-defined function is going to work, that is the flow of function. In today's video, we will discuss about the types of user-defined function. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. And if you like the video, please click on the like button and share the video to all your friends. So here are the list of the different types of user-defined function. So you have totally 5 types of user-defined function. Function with no argument and no return type. This is what a simple function that what we discussed in the previous video itself. The function will have no input and no return value. A very simple function, and that we discussed in the previous video itself. Please do check out the playlist. You'll get an idea like how this type of function with no argument and no return type can be used. Next, function with arguments. With arguments, it can be 1 argument or 2 arguments, and with a return type. Means it takes input as well as it is going to return some output also. So function with arguments and with return type is the second type. Then function with argument. It takes the input but it may not return any value. The third type. Next, fourth type. Function without argument. Without argument. No input. But it will return a value. Function with no argument is different. But function with no argument means you are not sending any input at all. But some value will be written. But how is this possible? So that we need to see. So here comes the concept of local variable and global variable. We will discuss that in separate videos. Then the last one, recursive function. So these are the different types of user-defined function. The first type we have already discussed. In today's video, we are going to discuss the second type. The next coming videos, we will discuss about the third, fourth and fifth. So let us talk about this second type, that is function with argument and with return type, taking input and some return value. So here is our complete program. So here a very simple program I have written, a program to perform the addition of 2 numbers using user-defined function. So here you have 3 parts of the function, that is function declaration, function call and function definition. So in the declaration part, what we'll do, we will declare the name of the function followed with its arguments list and return type. So here the return type of the function is float and the function name is add. And it is taking 2 arguments. One is integer, the other one is float. Here you can just remember one thing. We have not mentioned the variable name. It is optional actually. And if you mention the variable name also, there is no mistake in that. You can just say int x, float y. You can just mention the variable name also. If not mentioned, then also there is no issue in that. You can simply have the list of data types separated with comma like this. So it is taking 2 arguments. One is integer, the other one is float. This is declaration part and this is call and this is definition. How the call works, how the definition works, we will get into that step by step now. So let me start from the main function. So here is the main function. We have declared the function by name add, a user-defined name, 2 arguments it is taking and semicolon to declare that it has been declared. The declaration should have the semicolon. Declaration or what we call it as prototype. Execution starts from the main program. So inside the main, we have totally 3 variables declared. You can also write it in the next line also, no issues in that. So int a, float b, res. So we are taking two inputs, one is of integer type, the other one is of float type, and we perform the addition of two different data types. One is integer, the other one is float. So obviously the result will be in the float type. So the resultant variable is also of float type. Now, as usual, memory allocation I need to specify here. As soon as the compiler encounters the variable declaration statement, it has to allocate the memory for that. So totally we have three variables. One is A, the other one is B, and RES for result. A 2 bytes because of integer type, B and RES are of float type, so totally 4 bytes with respect to 16-bit machine I am talking about. Okay. The first message that what I am going to get, let me write the output screen here. The first message that what I am going to get is enter two values. So as soon as the user gets that message, you can have the message still more clear saying that enter one integer and one float. Not an issue, you can just say enter two values, and anyways when I say if I give two integer value also, the B will convert that to float and store. Say for example, I'll give 10 and 20. So the first one is percentage %D. See, there's a mistake there. So I need to say percentage %D and percentage %F. One is integer. So 10 will be stored in the address of A, and one more percentage %F. I have given 20, but it will take float value and it will be stored in the address of B as 20.00. Okay. All these are basic things we have discussed in the previous videos itself. Please do check out the playlist. Okay. Well, so we have accepted the values 10 and 20. The next thing that what we need to do is we have to invoke the function. So here is the function call statement. So how to call the function? We have seen that. Function name. In the previous program, we didn't pass any arguments, but here this is a function. This is a program which is illustrating the usage of function with arguments and with return. So we need to pass the arguments. I am passing the variable names. I am passing the variable name. One is A, the other one is B. So A is having how much? It is 10. And B is having how much? I have given 20.00. So as soon as the compiler encounters this function call statement, what it has to do? I have explained this in the previous video. I have explained how the flow of function takes place. As soon as the compiler encounters the function call, it has to check with the declaration to check whether that function has been declared or not. What is the function name? Add. Yes, add has been declared. How many arguments it is taking? Two arguments, A and B. One is of integer, the other one is of float. Is it returning some value? Yes, because this complete function call, you can just observe, it has been assigned to an integer value RES. Then it is returning an integer value or float value, not integer. Integer and float addition, you will get float, right? Integer and float, the resultant will be in float. So what is the return type? RE is of float type. What is the return type? It is float. So here everything gets matched. But coming to this arguments, you have some aspects of arguments. So what is that? Aspects of this argument means how the compiler is going to match with the arguments. There are some aspects of the arguments which talks about three things. One is the number of arguments. The other one is the type of arguments, and finally the order of arguments. These three things are most essential for the compiler to check. This is with respect to the arguments. Aspects of arguments means it has to check these three things. Number of arguments, type of arguments, and order of the arguments. Coming back to here. So here what we say, we are passing the arguments. What type of argument it is, I'll tell you. Okay. Now we have to check the arguments first. Number of arguments. How many arguments are there? 2. 1 and 2. Check the declaration. How many arguments? Data type we have mentioned 1 and 2. 2 arguments. Number done. Type of arguments. One is of integer type. The other one is of float type. Again go check. The arguments aspects number is done. Type of argument, one is integer, the other one is float. Yes, even that is also done. Finally, order of the arguments. The first one is integer, the second one is float. Yes, of course, the first one is integer, the second one is float. Again, this is also done. This is what with the arguments aspects, what the compiler has to check and what the compiler will do it. Right? Number of arguments, type of arguments and order of the arguments has to be matched with the declaration. Then I can say the function has been declared intact. If there is any mismatch in these three things with the call and declaration, then you get a message that is prototype mismatch. Okay. And even it has to check with the return also. This complete function call is assigned to a variable and that variable is of float type. Is the return type is of float? Yes. Everything will be matched. Then, so once it is checked with the declaration, the control will be to the definition part where the function is defined with the block of statement. Right. So the control will be to the function definition. You can just observe here. It is the function name add, return type is float and two arguments type, number, order, everything is matched. But here you can see new variable here x and y. Right. But here I have not mentioned here. If you are mentioning that variable name, the same variable name has to be mentioned here also. If not, no issue. But here we have some arguments. Here we have some arguments. So coming to the concept of types of arguments. The argument that what we are sending here, a comma b, this argument is called as actual arguments. They are called as actual arguments. So what is this actual arguments? Actual arguments, the first point that what you should remember is actual arguments are given in function call. It is given in function call. And this argument can be through a variable or it may be sometimes a constant also. I can just have the function call like this also with actual value, say 6, 7.2, something like this, depending upon the number of argument type and order. I can straight away pass some constant values also. If not, I can pass through variables like this. This method also we can follow. So here in the actual argument, so why it is called as actual arguments? Because they are the arguments which carry the actual value to the function. They are acting as input. So actual arguments are given in function call, they are acting as input. They are the actual values which are carried through variables or which may be passed as constant also. So when these values are passed, there must be some variables who receive it, right? So for example, if the guests are arriving to your place, you must be there at your place to receive them, right? In the same way here also, when I am passing something, there must be something to receive it. So here we have the formal arguments. Here we have the formal arguments. So what is this formal arguments? They are the arguments which are created formally to receive the values. Coming to the point where these formal arguments can be placed here also in the declaration. If I have that variable name mentioned here itself, int space x, comma, float y, semicolon, then these variables which are given in the declaration itself acts as formal arguments. But sometimes we don't mention that. We straight away mention in the definition part. So these formal arguments can be in the declaration or it can be in the definition part. But usually it will be in the declaration part itself. Fine. So formal arguments are the arguments which are given in the prototype, that is in the declaration part, or it may be in the function definition, which are used to formally receive the values. So here what happens when I say x and y, new memories will be created. So x is created of integer type, x is of integer Then y is a new variable which is created of float, because I am sending one integer value, so obviously I should have integer. I am sending one more float, obviously I should have a float to receive it. So actual arguments, formal arguments, hope you have understood with this. Actual arguments given in function call, formal arguments given in declaration or in the definition part, right? And aspects of arguments. So this complete part, that what you can see here in the main function, it is called as calling function, the function which is invoking one more function. And the function which is invoked, it is called as called function. Calling function, called function. So many aspects we discussed here. So formal arguments which are formally created to receive the values means x is receiving how much? 10, and this y is receiving how much? 20.00, because it's float type. Okay, fine. So I have received the value x and y. The next thing that what I need to do is I have to do some operations on that. And this program is dealing with addition of two numbers. So what I am doing, I am performing the addition. And I say simply return x plus y. What is the value of x? It is 10. Value of y, it is 20.00. Receive with new formal variables. X plus y. 10 plus 20, it is 30.00 written. How many value a written statement can return? It can return only one value. It can return only one value. The written expression can return maximum of one value. That's it. And where it has to return? To the place where the function was called. Right? So return 30. Compute and then return. You can have an expression, or what you can do is you can have a local variable. You can say int z, then you can say z equal to x plus y. Then you can say, instead of writing x plus y here, you can say return z. Like this also you can do. So here's why to waste the memory. So we have to write the program in such a way that we use the memory efficiently. We shouldn't use the memory and we shouldn't simply waste the memory. So we have to write the programming in such a way that we effectively utilize the memory. That is what the good practice and the efficiency of the program. So return, I say x plus y. So I need not use one more memory, do the computation and then return. I can do two tasks at a time. Compute and then return. Return x plus y. So it is going to compute x and y. Then the result return. To the place where the function was called means to the place where the function was called, it is here. So what is the result of add of a comma b? It is 30. Store that in res. So here what I got in res? 30.00. Float. Written float. So 30.00 is written here. Then I print a message. Result equal to, one more mistake here I have is percentage f. Res is of float. Percentage f printing res value, it is 30.00. So this is how the function completely works. So we discussed many concepts here, that is actual argument, formal argument, calling function, called function, aspects of the arguments, all these things. See, once the control is back to the place, it will take the control to the next line. So printf result equal to, I'll get the result. See, execution starts from the main program, control will go to the subprogram, and again the control will be back to the main program, that's the place where the function was invoked, and the remaining statements gets executed, printf gets executed and gets ch, and the program ends. Program ends here. See, this is what the program, this is what the subprogram. Got it? Hope you have understood with this. This is what function with argument and with return. So let us see the actual execution of this program. So here we have the complete program. So this is what the function declaration, this is what the function call, and this is what the function definition part. So function with argument and with return. So I have explained the flow of this program. So let us save this program, execute the program. See, enter two values. Let me give 20 and 30. See, result is 50.00 because it is going to perform the
result with two different types of values. One is integer, the other one is float, and result will be obviously in float. So it is 50.00. So this is what with the program function with the argument and with return. That's all for today's video. See you in the next video. Till then, take care. Bye bye.